Hi everyone, welcome back to this week of Prairie Math League. I'm Andrew Waring, and today we're going to be going over the solutions for the elementary school round 150 of the Prairie Math League. Okay, so let's get right into it. So the first question, a collection of coins includes only pennies, nickels, dimes, and quarters. Using the coins in this collection, it is possible to create any amount of money less than $1. What is the smallest possible number of coins in the collection? The options they give are 10, 7, 11, 13, and 12. So first thing, let's so 90 let's just set this as 99 cents is the maximum amount of coins that is the maximum value that they need to create. And the minimum amount of coins you need to do so would be 3/4. So I'm just gonna write like this. So that'll give you 75, 3/4. And then 2 dimes, 2 times 10, which will actually bring you to 95. And then, uh, 4 pennies. So 4, 1, yeah. So the most you'll need would be, sorry, 9, yeah, 9 coins to make 99 cents. Now we can look at trying to use these coins to make other possible values in the uh, from 1 cent to 99 cents. So we can kind of split up into 4 ranges here. So first range is 1 to 24 cents. Next one would be 25 to 49 cents. And then next one 50 to 74 cents, I believe. Yeah. And last one is obviously 75 to 99 cents. So we can check if these values, I'll just put like these quarters, dimes, and penny. So we can check if these values actually fit with each of these. So right away we can notice a problem. In the 1 to 24 cents range, we see that it is very difficult to do 5 cents because a dime is 10 cents and we only have 4 pennies. So between 5 cents, 6 cents, 7 cents, it's all a problem. So we're either gonna need to add 1 penny, so it becomes 5 pennies right here, or we can add a nickel, which is 5 cents on its own, and it's also just adding 1 penny. But then another option occurs. So if we only add 5 pennies, if we add another penny, it becomes 5 pennies. So yes, we can do 5 cents, but how are we going to do 6 cents, 7 cents, or even 9 cents? So now we look at what happens when we add a nickel. So when we add a nickel, we get the 5 cents automatically just with 1 coin. And then plus each penny that we add, we can get 5 cents, 6 cents, 7 cents, 8 cents, 9 cents. We can't get 10 cents, but luckily we have dimes here to cover up for us. So 1 nickel will actually be the better option to add because we can now get all the numbers from 1 to 24. So, and if you don't believe me, we can break this down even more. So from 1 to 4 cents, you can use, let's write this. 1 to 4 cents, you can just fill up with 4 pennies. From 5 to 9 cents, you can use a nickel and 4 pennies. 1 nickel and 4 pennies. And then from 10 to 14 cents, it's a dime and 4 pennies. And then from 15 to 19 cents, 15 to 19 cents, you can use 1 dime, 1 nickel, and 4 pennies to get the whole range in that. I have to move this back a bit. And then lastly, from 20 to 24 cents, you use 2 dimes and 4 pennies to get that desired value. All right. So there you have it. We can make any amount of money, 1 to 24 cents, using what we have, pennies, nickels, and dimes that are available to us. So now let's talk about the other 3 ranges. All right. So if you notice something, basically 25 to 49 cents is another 24-cent difference range, same as 50 to 74 and 75 to 99. So basically, if you notice, we haven't used our quarters yet, and that's for a specific reason. Because when we add a quarter into here, we can go from, let's say, 25 to 29 cents. Sorry, 25. Yeah, 25 to 29 cents just by using a quarter and 4 pennies. So a quarter automatically gives us 25. And then when you find this pattern, you will realize that everything we do up here with 4 pennies, 1 nickel, and 4 pennies to get these ranges in the 24-cent range, we can just add a quarter to it to get everything down here. So we add 1 quarter added when it's in the 25 to 49 cents range, and we can actually add 2 quarters plus all the pennies, nickels, and dimes to get any desired value in this range. And then we can use 3 quarters to get any desired value in this range. So when we tally up the coins, the least amount of coins we need to get every single value from 1 to 99 cents, it will be 3 quarters, 2 dimes, 1 nickel, and 4 pennies. That's the minimum amount of value you need. So let's check how many we have. So the total amount of coins we have is 3 plus 2 plus 1 plus 4, which will give us a grand total of 10 coins. So 10 coins. So the answer to number 1, to question 1, is A. So I'm just going to quickly draw that. So 1 is A. All right. Let's move on to question 2. So question 2, let's read the question. How many positive integers between 10 and 2016 are divisible by 3 and have all of their digits the same? The options they give are 9, 12, 6, 18, and 3. So the first step, let's just list out all the positive integers that have all their digits the same. So we have 11, 22, 33, 44, 55, 66, 77, 88, 99, 111, 222, 222. And once we get to here, we enter the 4 digits. So 1111. We can't do 2222 because that would be above 2016. So we have our list right here. 11, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I believe there are 19 integers right here. Now let's go check if they're divisible by 3, because that's what the question is asking for us to do. So 11. So the rule we actually use to check if something's divisible by 3, let me draw it out, is if the sum of the digits has to be divisible by 3. Sorry. You know what? I'll just write it out here. Sum divisible by 3. Sum divisible by, oh my bad. Yeah. Sum divisible by 3. I'm just gonna put it up here. Okay, what? undo. So sum divisible by 3. Put that up here. And then I'm going to erase. Okay. Let's try that again. Sum divisible by 3. All right. Yeah. So 11. So 1 plus 1 equals 2. So it's not divisible by 3. So it is not, does not meet the requirements. 2 plus 2, 4, is not divisible by 3. 3 plus 3 is 6, and that is divisible by 3. So that would be, we'll just write a C, like as a check mark, sort of. 44. 4 plus 4 is 8. 8 is not divisible by 3. You know what? For the ones that are, I'll just put a C next to it. So that's not that as confusing. C means it meets the requirements. 5 plus 5 is 10. So no, let's write 10. 66, 6 plus 6, 12. That is divisible by 3. 7 plus 7 is not divisible by 3. 8 plus 8, which is 16, is not divisible by 3. 9 plus 9, 18, divisible by 3. 1 plus, okay, let's use a strategy here, okay? So since there's 3 digits and they're all reoccurring, it's basically, the sum is basically 3 times whatever digit it may be. So automatically, all of these are all divisible by 3. You don't believe me? We can try out some random numbers, okay? So 1 plus 1 plus 1, 3, that is divisible by 3. Now let's jump to 5 plus 5 plus 5, which is 15. That is also divisible by 3. Let's try one more, and then before we test this pattern, so 8 plus 8 plus 8, that is 24. So that is also divisible by 3. So we can now assume that all of these will be divisible by 3 because it is just the sum of the 3 identical digits will just be 3 times that one digit, if you sort of get what I'm saying. So these are all divisible by 3. Let's see. They all meet the requirements. 9992. And let's look at the only 4-digit number, 1111. So that'd be 4, that is not divisible. So basically, these are the numbers that meet all the requirements. Now it's counted up. So 33, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically, I just counted all the numbers that have a C beside them. Just count the number of C's, which are the ones that meet the requirements. So the answer is 12, as I counted. So let's see, 12. So question 2, 12. So the answer is B. And we're just gonna clear all the drawings, redraw. So answer number 1 is A. Answer number 2 is B, 12. All right, let's move on to the next question. So question 3. So the mean of a set of 6 numbers is 10. If number 25 is removed from the set, the mean of the remaining numbers is, okay. So I'm actually gonna be drawing this one. So since the mean of a set of 6 numbers is 10, that means the average, so the 10 times 6 should be the sum of the total, right? So 60 is the sum of all the 6, is the sum of all 6 numbers. So if the number 25 is removed from the set, we have to subtract it from the sum as well. So 60 minus 25 will equal 35. So 35 is the sum right now, sum that we have right now. And since we also removed a number from the set of 6, we only have 5 numbers right now. Sorry, yeah, 5 numbers. 5 numbers. Yeah, you get it. So the sum we have is 35, and we have 5 numbers. So the average is the sum of the numbers plus the number of numbers, if that makes sense. So the average of this new set of 5 numbers will be 7. So 7 is B. So 3 is B. I'm gonna erase now. And let's move on to question number 4. Right, yeah, 4. Okay. Oh, this mouse. Okay. So let's 2 5-digit positive integers are formed using each of the digits from 0 through 9 once. What is the smallest possible positive difference between 2 integers? So let's look at this question. So let's put b x as the larger of the 2 numbers, and we'll put d lowercase d x as smaller number. And the x's represent the to fulfill the digits, right? They all have to be different numbers. So the options they give us is 0 to 9, and we can't repeat. So in order to have the smallest difference, we want these 4 x's to be the smallest, these 4 x's to be the smallest value possible. So yeah, if you sort of get it. And you want these x's to be the largest possible value, so that when they subtract, they create the smallest difference. And you want d and this d and this d to have a difference of 1, because anything above that will result in a basically something 10,000 of a difference. So we don't want that. So let's take obviously the 4 smallest numbers in from 0 to 9, which is d 0, 1, 2, 3. Then down here, the largest numbers from 0 to 9, without repeating, d 9, 8, d 9, 8, 7, 6. And what we have left here is 4 and 5 from the list. So since capital D is the larger number, we'll put 5 over here, and then lowercase d smaller number 4 over here. So now we calculate the difference, right? So 50,123 minus 49876 will actually give us 247. 247. And let's look at the answer list right here. So 247 is C. So the answer to question 4 is C. Let us put question 5, question 6 there, and we get to it later. And so yeah, let's go to question 5 now. Ahmed chooses two different items for a snack. His choices are an apple, an orange, a banana, and a granola bar. How many different pairs of snacks could he choose? So let's set A equals apple, B equals banana, O equals orange, and G equals granola bar. So let's just physically do the parents. All right, so A and B, apple and banana, A and O, apple, orange, A and G. So apple as first of all paired with everything. Now let's look at banana's parent. So banana can't pair with apple because they've already paired right here. So they're gonna go banana and orange, banana and granola bar. Now let's look at orange now. Orange has already paired with apple and banana, so we can only pair with granola. Granola has paired with all the other ones, so it's just empty. So we count the list here, we get 6. And so the answer is D, 6. So answer to 5 is D. Let's move on to question 6 now. Question 6. Oh, the positive factors of 6 are 1, 2, 3, and 6. There are 2 perfect squares less than 100 that have exactly 5 positive factors. What is the sum of these 2 perfect squares? Alright, so first, perfect squares, I'll just list them out. They're 1, 4, 9, 16, 25, 36, 49, 64, and 81. And we're talking below 100, so 10 squared 100 will not count because it says there are 2 perfect squares less than 100. So these are the perfect squares list that we have. And if we look at the individual factors of them, we can see that 1 only has 1 factor, so it's 1. 1, we'll just go 1. And 4, there's 1, 2, and 4. So the perfect square of 4 has 3 factors. So as you can see, we're going to go down the list, but I'm going to sort of reduce it, and you can sort of try it yourself. Yeah. So we're trying to find the sum of the 2 perfect squares that have exactly 5 positive factors and that are less than 100. So 1, 4, let's just continue then. 9, 1, 3, 9, 16. Now pay attention. 1, 2, 4, 8, and 16. So that's actually 5 factors. So let's mark that down and we can save that for later. And now 25, we're continuing down 1, 5, 25. Okay, we're going back to the 3 factors. Now I'm gonna save you some time here. So once you actually find out all the factors, you continue 36, 49, 64, 81. Once you get, here I'm in the right place. Once you get to 81, you'll find the factors are 1, 3, 9, 27, and 81. That's another 5 factors. And you'll find that these 2 are the only ones who have 5 factors in this list. So they're 16 and 81. So what are the sum of these 2 perfect squares? The perfect squares are 16 and 81. Let's just find that real quick. 16 plus 81 equals 97. So the answer is 97E. So the answer to question 6 is E. Oh, no, that's not the right one. Answer to question 6 is E. So I'm going to write the final. So answer to question 1, A, 2, B, 3 is also B, 4 is C, 5, D, and 6, E. So you should be getting A, B, C, D, E as your answer. So if you got this, congratulations, you got all the questions right. And so yeah, that's it for this week of the Prairie Math League solutions for elementary school round 150. The date today is October 8th. Thank you for watching this video. I hope you learned something. and I'll see you next week.